Okay, I wanted to take a few minutes to talk a little bit about my two companies that I have started and explain a little bit about what I'm doing with both of them. I was a senior engineer at Verizon Federal, and I received a bid from the FBI actually to build a content store for their video systems. And so essentially the FBI wanted to take all of their security footage and essentially make it usable. So the way you do that is you start building indexes on cameras by site, by time, by day, and you try to make the video usable by digitizing it, taking it from whatever media it's in and putting it in a searchable format. So the FBI had been using these local recording systems that had, for example, taking a specific branch and would record hours of tape. And certainly they do that every day. But it's not really useful until you have an event. So some kind of accident happens, you create a case for it, and then you go back and try to find video footage that fits into the case in sort of an investigative model. So as you do that, 99% of your video is unusable. It's not searchable, and it's not really relevant. So you end up having cameras that are rolling tape, but usually most of the tape is never used and isn't even relevant. But what we at Verizon started thinking about was, well, what if we could overlay enhanced metadata like your location records from your cell phone with a video camera. So I'm on making a movie today and I'm carrying a cell phone. My cell phone has a metadata tag, and I can relate this phone to a camera that's fixed in a geographic proximity radius to where the phone is. So when I go to pick up that event, I can not only look at the camera and the footage, but I also can search proximity radius of the camera itself, and I might be able to identify whatever objects are in the camera's purview. So that is sort of a reactive approach where I'm correlating a camera to proximity data. So you can also do it in reverse. You can say I'm carrying a phone and I'm walking down Main Street, and I can try to query the video that's attached to it and certainly build a search engine. So what we started to do was to say, okay, how can we approach this project? And as a broadcast engineer for Vivix, which was part of Level 3, I had CNN and Fox as my customers. And what CNN was in process of doing was digitizing all of their segments. So for example, if one of the anchors was on TV, let's say John King was doing a political segment with Joe Biden, at the end of the segment, John King would save that segment, he'd upload it to a server, and he'd apply metadata tags. The metadata tags would be like the date that the event was taken, the physical location, and who's in it. So I create searchable records. And what CNN had actually done was they had bought a media archival platform from Sony that allowed them to search for any of those tags. So you could search for Joe Biden or search for John King, and it would return all the results set. So I was trying to marry the two issues, and I responded from Verizon with that as my answer, is that I would use a Sony content store which was searchable and take all the security feeds and sort of systematically apply a metadata tag to them about where they were located in the proximity radius, and then from Verizon cellular services we could add a proximity query tool as a second search. So the idea was that we could start making all this video useful and relate it back to a tag, which is a cell phone. So now the Federal Bureau goes to all federal facilities. So every foreign embassy, all the U.S. Their own branches and bureaus. They have dark sites. They're on most of the military sites, and they have small branches in places like the Congress and others. And so the Federal Bureau's own video systems are expansive, but the agents also wear body cams, and there are cameras in the cars as well. So they're taking footage all over the place. And then what we responded to at Verizon is we could include other sources like traffic cameras on state boundaries and the like that are relevant to the FBI. Now the reason that's all important is because FBI research shows that, for example, when it gets to hostage rescue situations, after 48 hours, most of the time the person who's kidnapped is not recovered. And they've also have stats where like 99% of the time those issues have crossed state boundaries and police boundaries, so that an analysis of location processing across borders is relevant to pretty much everything that the FBI is doing in law enforcement. So we started out with that as our goal, and while we were working on that, the Secret Service came to us and said, well, there's another issue, and that's when somebody with a cell phone comes in and marks your location. So for example, the president's children or members of Congress can be marked when they go to the coffee shop. Just essentially scrolling through, I can set, Congressman A's name and set his very position. So if you have a foreign intelligence agency and they have a scroll bar, they can use their own cell phone to mark location tags and build historical records of where you are on a daily basis. And that, in turn, affects your overall security, not just in the short term, but in the long term. So the Secret Service had an interest in the same type of technology from a protective services basis, and then we started expanding it, saying, well, in order to do that, we need to create, first of all, proximity domains, and then we have to process all the tags in them. So a cellular tower is a proximity domain. A single cell, like here in Myrtle Beach, might be 3 towers, but moving inside that cell are thousands of cell phones. And of course Verizon has one, AT&T has one, Sprint has one, so they all have their own cells. So to get a true proximity process, I have to cross the cellular boundaries. So let's say, for argument's sake, you have all the video and you've stored it on a SAN or some kind of network disk. You have the video appropriately tagged like CNN was doing, and you have proximity domains from all of the vendors. That's pretty much what the federal government has. They know where everybody is. They have their own security footage. And when they need to, they go out and issue a subpoena to gather, let's say, the Circle K's security footage to import that into their system as well. But essentially they're always creating a case first and then attaching video to it. And what they'd like to do is to be more effective in that case, so they want to be able to search and attach records. So for example, security event happens, I want to know who's around it, who are the potential witnesses, who are the potential suspects, and that makes their job a little easier. So that's essentially where law enforcement is going in the future. So the use of electronic tags, not just from cell phones, but you can also tag location, like when you swipe an ATM card, or when you go use any other process like a key fob on your door as an access point, can be geocoded. And the U.S. Army also has technology where you can geocode voices. So if you hear my voice into a microphone, that microphone itself can identify the range of which I am nearby. So my voice can be geocoded as well. So when you start processing those geocodes and attach them to a record, that record might be my social security number or my driver's license, or it could be my billing telephone number, and you might want to be able to search any of those items. So if you have a court process, a warrant, a restraining order, those kinds of things all can be processed by electronic tags. So the idea of Capital Technology was to build this data store and then use traditional Verizon services on top of that. So the disk services, the wireless, the things that we didn't want to expose to this national security program, we decided to make separate. So Capital Technology was intended to be a wholesale division of Verizon Federal that was just going to work with AT&T and Sprint to collect this data for the FBI. And of course the FBI and the NSA already have a lot of metadata, which I can't talk about, but essentially they have their own data stores that you can pull in. So the idea was we have to be able to create a database environment that would scale to the size of the internet. So if we do that, it ends up being several orders of magnitude larger than Hughes Telematics, which Verizon had just acquired, but did have sort of military level encryption devices that did process location and fleet information, but they did it in a secure way, and they could do it over not only satellite but also cellular services. So Verizon, by buying Hughes, ended up having all the other things that I needed, and we had partnerships with the FBI's current vendor, who was a Verizon wireless customer, and so the body cams and the like, we effectively were already exposed to our network. So we made a bid to the FBI, and I was told in June of 2013 that we had won, that our model was compelling, it was exactly what the FBI wanted, and it was also what the Secret Service wanted. The problem was the NSA already had all the data we needed. They didn't really want us to know the formats or who was keeping it, or even the people involved in operating it, which they sort of made it all dark. So they just made an offer to Verizon to acquire our bid essentially, and everything that went associated with it, the designs, the architecture, how we were going to process things. And then they essentially offered, Mr. Obama called me personally and said, I'll pay you $200 million for this. So the design itself sounds simple, but when you start putting all the pieces together and overlaying it on a PSTN framework, it's about as complicated as the internet itself. So it's not the internet, it would be a layer equivalent to the PSTN riding in its own planet, sort of a interdomain metadata processor. So that's what I decided to do. That's what I bid, and we were told that we had won. But when I came back to the company, Lowell McAdam, who was our CEO, and my division president said that they hadn't approved the ICB, or the individual case basis program, because they didn't have all the cost inputs. They didn't know what it would literally require to build, because I hadn't done the formal engineering analysis. Now, I usually do my own desktop version of that, and I have 30 years of engineering experience, and so my numbers are usually within 5 or 10%. But when you go to the finance company to actually write paper, a CenturyLink, a Verizon, an AT&T always requires the head of the division to sign off on it. So to get a management approval on a new product offering, you end up having to get the head of the NOC, head of field ops, the head of the product management group, usually a business development resource, and 2 corporate sponsors. So you end up having to get on the order of 7 to 8 signatures. And in this case, the deal at the time, Verizon Wireless was partially owned by Vodafone, and in a national security context, we would have had to inform the UK government, and I would have had to go to MI5 and MI6 and get their blessing as well. And so what sounded like an easy project was something that Verizon just said, look, we can't deal with any of this. Now, to extend that fabric from the U.S. Army to the Navy, or even to the Air Force, you have to be able to get into their devices, into their command and control systems, and that requires somebody like a General Dynamics or Lockheed that's in that security sphere, and they all have their own classifications. So what I did instead is said, okay, I have a location store, we can send a target package to a drone, or we can send a target package to a B-2 bomber, or even a nuclear submarine, and that was essentially what the Secret Service wanted to do. They wanted to be able to weaponize a location from a cell phone up to a threat management system, and then that threat management system have any option that the director of the FBI or even the president wanted to take at any one point, to the point where we could actually, for example, in the Capitol riots, we could have had a destroyer sitting in Washington Harbor shoot tear gas onto the campus grounds without rolling SWAT. That's just the type of capability that we have with a metadata system. Now, as you start getting into processing tags, cellular services usually go up to 2 miles high, so you can start to impact defensive capabilities like for cruise missiles, low-flying airplanes, delivery UAVs can be tracked, etc., inside of a cellular location processor. So we started with that. You can extend to sports, virtual reality games, you can get into social media extensions and the like. So Capital Technology, what we're intending to do with it, once you have all the data, you got to say, okay, well, how can I present that to a customer? You have to have a web interface, a REST interface, and you have to be able to help them achieve their goals. Now, the federal government has huge numbers of engineers, and they can do this on their own, but a Bank of America or a Chase don't, usually. So you have to help them, at the minimum, define the project so that they can pull in their own developers or hire some other people, or even hire you to just do the work for them. So to get that to a customer usable level, you have to be able to interface with their e-commerce systems, and that gets into web delivery and marketing systems. So my initial thought was capital technology